Okay, hello and welcome back. Today we're doing part 4 of building AI music improviser in Maximus P. So today we're going to add the, four of the other chroma analysis objects. So instead of just having MFCCs here, we will have chroma, spectral shape, melband, and pitch analysis. Using the chroma analysis objects. So let's start with chroma. So chroma is, for those who are music theory folks, chroma is pitch class. So it is what pitch it is no matter what octave, which from a perceptual point of view is very relevant. Probably in most cases more relevant than exact pitch, at least for what I'm going to want to be doing. So let's create the object fluid.chroma and let's have some FFT settings. Larger is maybe a bit more accurate for chroma. So do it quite large there. We're going to want to normalize with the chroma object. This is just from experience, I find that it is more reliable. I'm going to set the min frequency to 30 and the max frequency to, let's say, 18,000. Okay, from here, we're going to want to have this stuff and then rename it. So we'll have fluid stats. Oh, also the number of chroma. So it can be 12 if you want to have 12 tone equal temperament, or at least in terms of how it's analyzed, but it maxes out at 24. So we'll do 24. So quarter tones effectively. So let's do fluid.stats 24. I'm gonna make the history half as long because our FFT window is so much larger. And there we go. You see that's adjusted. Now, it's going to, I believe, go between 0 and 1, and this multi-slider is currently at -60 and 60 for the MFCC. So we'll go from, let's go from -0.1, just for a little space at the bottom, to 1 and see how that looks. Bring our ADC in. Ooh. Good. Maybe we can bring it down to 0.7. Ooh, that looks good to me. Okay. In fact, I don't really care about that negative space, so let's just go from 0 to 0.7. Yeah, that looks good. All right, and now our list to buff, we don't want to be writing to that. We want to be writing to chroma.live, and so chroma rather underscore live, and oops. And 24. Great. Okay, so that's our live input analysis for chroma. Now let's build our grain and slices analysis for chroma. So to begin doing that, let's actually go into here and let's do grains first. So I'm just going to copy and paste my object there and rename it to chroma grains. And then I'm going to take the grain thing here that I made, copy it over here and rename this to chroma grains and chroma grains, corpus mono 508. Okay, great. So let's go in here and have a look. So right now it's just the MFCC analysis. So we're going to modify read only, and we're going to change this to chroma analysis. So we're going to have to redo how the analysis happens in there. The other thing we're going to have to redo is what it's referring to here for the live matching. So for that, we'll just want chroma underscore live as the buffer rather than mfcc underscore live. Otherwise, everything is named using these arguments, as in the number one thing. So that will change its name and be a unique name, so that won't conflict with the earlier analysis. Okay, so that all looks good. Now we just have to switch out how this analysis is done. So all this code is going to be the same except for this object here. We are going to need to do our buff chroma analysis. So let me just have the settings here so they're the same for the live input as well as the non-live. And we're going to want to have the numchans and the source be the same. So I'm going to go ahead and change these settings first and then change the name. So 4096, 512, 40, oops, 96, not 69, 96, okay. Numchans 1, starting coefficient, that doesn't apply, there are no coefficients. Source is the same. At normalize 1, at min freak 30, at max freak 18,000, and we want 24 chroma and fluid buff chroma. Okay, good. See if we got any. Ooh, look at all that. Oh, right. That was before we changed the buffer name. Good. So from here, I think it all is exactly the same. So let's go ahead and save that and we'll test it out. So now I've already recorded myself making some boops and whatnot in here. So we can use that. There's not a lot of pitch data in there, so let's record a little more. And now. Great. Okay, so we have our chroma analysis working, and now for live matching, let's see if that works. Actually, do that. Great, seems to be working fine. Okay, so that is how we change the grain analysis to be for chroma. Now let's go ahead and do it for the slices. So we'll do the same thing here, chroma slices, and then I will copy this. Oh, actually, let me redo these just to have all the same audio in there. And of course we'll need to get new slice points. Oh, because I'm doing continuous sound there, the slice points are going to be weird. Okay, we'll have to record some new slices so that it works a bit better. Okay, so chroma slices, and then I have the correct names there. So if I go in here again, I want to change to modify read only, and I would like to change this to chroma live. And from here, I will go into here. Well, actually, let me change the name of it first. Chroma analysis. And here we want to have the exact same settings as in the other one. So in fact, I will go into here, oops, and just copy that. Then go back into here. Oops. And paste it. Okay. Oops. Just being obsessive there. Okay. Great. So I believe that is it. So let's see if that works. Oh, well, let's do a new recording with more distinct attacks. Bop, 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 bop. A little less. Okay. It's got a lot of silences in there. Okay, let's try this. The slicing's not brilliant, but let's see if we can get it to work anyhow. Ba, 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 da, 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 da. Okay, let me try that with a sound file. Right, this will be long sung notes. And let's get some attack points. This might take a little longer. It's 5 minutes of audio. We should get lots of dots. Good. Ooh. Cool. All right, that's working. One thing that I'll probably test out later on is if it works better with, say, 19 chroma or even 12 chroma. It's possible that it actually is sort of more accurate with fewer chroma, and might play around with FFT settings as well. But in any case, it's working. Let's test out the chroma grains. Ooh. Cool. Okay, so now I'm going to do the same thing for all of the other ones, and I'll probably just Okay, so I've slowed it down now for the pitch analysis. So for pitch, we don't need the UMAP because it's only for fluid pitch analysis. It's the pitch and frequency, and then also the pitch confidence, which is super useful. So we're just going to do things slightly differently for this one. Change this to pitch grains, and then paste it over as we've done before. So pitch grains, great. Then from here, modify read only. So here it should work just going straight from the standardize to the normalize without the UMAP reduction. And we will see this in a second to make sure. Okay, good. Just want to get my pitch settings now. So those are FFT settings, okay. And back in here. Pitch analysis. Change this to pitch underscore live. Then in here, fluid dot buff pitch. Keep the source and change the FFT settings. And then let's see if that works. Oh, we'll also need, oops, have this PR pitch live, and it's only 2 samples long. And this should be right into pitch underscore live. Great, okay. So yeah, pitch and confidence. So in the silence, it's very not confident. Great. Here's where the grid actually comes in handy a lot. Okay, great. So that's the exception for pitch. So I'll speed it up again as I do the slice version. Okay, so there we have it. We've added now, we have MFCCs, chroma, spectral shape, melbands, and pitch. All this analysis is complete. So let's just test this all out. I'll record myself making some sounds. Okay, this is recording myself speaking. Now I'll sing some notes. Ba 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 ba. All right, let's get some attack points on that. Get a bit fewer. There we go. Now let's do all this analysis. See, it's still pretty snappy on the shorter sound files. Spectral, mel grains, mel slices, pitch, and pitch slices. Great. So for pitch, melbands. I find melbands generally to be quite interesting. They're just frequency bands, but you can see they capture a lot of the timbral information as well. So you see all the whistles down here. All the sounds are over there. All right, spectral. The spectral shape I don't have as much experience with. This is the first time I'll be using it really. See, the whistles are sort of between different labels, which is a bit funny. Okay, this is so there may be a way to refine it, maybe using only some of the spectral descriptors or something like that. could make it better, but in any case, it's there. And chroma. Chroma is interesting because it's really about the chroma, right? The pitch class rather than the timbre at all. So if we do something like this, so you get much more timbrally varied matching, but that because the pitch class is such a strong perceptual thing, the matching works quite well. And then of course MFCCs we've already played around with. It's very good for timbral organization. Yeah, see the MFCC organization is definitely tighter than the other ones, timbrally. Okay, so we now have all of our basic sort of data in machine analysis and learning, and we can actually maybe start trying to be a bit more creative with it from here on. So that is the end of part 4, which is really just sort of the end of the setup for the whole thing.